Hi there, this is Jacob Nash, Engineering Lessons, and this is Unit 4.1, Lesson 2, Statistics. This is a review of Intro to Engineering Design, so if you took that class, you might already know most of this, but it's a good refresher because you'll need to know this for exam. So, first, actually, as a reminder, if I haven't said this before, all pictures and slideshows are taken by me. So, also on the same thing on Jacob Nash geometry lessons. If it's a picture of like nature, I took it. I took this in the Blue Ridge Mountains. So, but that doesn't have to do with it. So, um, first, let's look at qualitative versus quantitative data. Qualitative data is data with names, labels, or colors. So this is also called categorical data. So it's like if you're doing like a bar graph and it's like how many people like chocolate ice cream or vanilla ice cream, things like that, it doesn't have a value associated with it. Quantitative data has numbers. If you know about quantity versus quality, that's easy to remember, or just remember that there's an N in quantitative. Um, Also, this is called numerical data, and it has numbers, so you know what numbers are. Let's look at different ways to display this data. You can use a histogram, and I'm sorry if you can't read that. I don't know why this was transparent background, this um, picture I took in. So this kind of looks like a bar graph, but it's not the same thing. Um, Here's what the difference is. So if you see the numbers down here on the x-axis, on a bar graph, the numbers would be in between, like in the middle of the bar, but on a histogram, they're at the edge of the bar. So that's the difference. That's how you can tell the difference. It measures frequency, so that's also something you can look out for. Frequency polygons also measure frequency, so they measure the same thing as histograms, but they have lines instead. And this is not the same thing as a line graph. So if you think about it, you know those like analogies that you can make. Histogram is to frequency polygon as bar graph is to line graph, because bar graphs and line graphs measure about the same thing, and histograms and frequency polygons measure about the same thing, but they both look the same, but they're not. And once again, the same thing with the line graph. Is that a line graph has the tips of the point will be right at the value on the x-axis, but in the frequency polygon, the tip is in between two numbers. So, not the same. Pie graph, you know what this is probably. It measures percentages. Then mean, you also probably know what this is. You just add all number to solve it or to find it. You add all the numbers and divide by how many there are. And this is the formal equation for it. X dietris, which is, well, there's different things can be that are the variable for mean. It can be x dietris, which dietris is two dots on top. It can be x with just a flat line on top of it, or it can be something that's a Greek letter mu that looks like a upside down H. But and we'll look at that in a minute. But in this case, I just used x dietris because I could actually type that on my keyboard using the international keyboard and the quotation mark key. So it equals, you see that? That means sum of the Greek letter, sum of x, so x, the numbers that there are, divided by how many there are, n. So let's see if we can find, well, it's right there, but here's how you would do it. 2, 6, 7, 9, 12. You need to add all those. You get 36. Divide by how many there are. 1, 2, 3, 4, 5. That equals 7.2. Median is the middle of a set of numerical numbers, and So you just have to cross out one on each side until you get to what's in the middle. So you can see that 19 is in the middle of this set because 1, 2, 3, 4, 5 on this side, 1, 2, 3, 4, 5 on this side. So if there's an odd number of values in a set, it's a lot easier because it's one number, but if it's an even number of values in a set, then there will be two medians. But there will be two numbers that are in the middle, but to find the final median, if there's two, so median of 2, MT, will equal the higher number of the two divided by the lower, and then whatever that number is, add it by the lower. So we do 18 divided by 15, high divided by low, that's 1.2. Add that with the low. Low is 15, so 1.2 plus 15 is 16.2. So the median is 16.2 of this thing. Even though you don't see that number there, that's what's in between 15 and 18. Mode is the number that occurs the most in the data set, and in this case it's 7. But this one's probably seems like the easiest to find, but it's sometimes hard. But what I do is I put the numbers in order, and that's easier to find the mode. So the range is the difference between the highest and lowest values. So high minus low. So the highest value in this set is 38 minus 1 is the lowest, which equals 37. So all these things are pretty easy to find. You just got to remember how to find them. Standard deviation. This is something you might remember, and you're like, oh, I hated that thing. And unfortunately, I'm not going to say how to solve for standard deviation in this case. That is something for Intro to Engineering Design, IED. Hopefully you took that class, if that was the case. So, yeah, you might want to look up a video about how to do that. Maybe that, like, chemistry teacher person, whatever that channel name is, does a video about that. So there, you can do sample or population. Sample is just part of the data set, and population is the whole data set. So let's look at what the variables are. S and sigma, which is that O with the like thing on the side or on the top, means standard deviation. But if it's a S, it's sample, and if it's a sigma, it's population. Once again, sorry this thing's so dark. Hopefully you can see that, but that's right there. Sigma equals square root of sum. You see that right there. So once again, this symbol means the sum of. This is lowercase sigma, this is uppercase sigma, if I'm not mistaken. I'm not very good with my Greek letters. Sorry if that's incorrect. X, which that's supposed to be lowercase, sorry if that's uppercase. That means the value that you're given. And then X diatrice, X with a line on top of it, or mu, which is a Greek letter that looks like an H that's upside down, is mean. And then italicized to n is the number of values in the set. So you can see how to do that. Now, also can be uppercase n. Sorry, I forgot to put that in there. It's lowercase for sample. It's uppercase for population. Thank you for watching, and that'll be it for this unit. Sorry that there's not as much videos for these last few units, but I need to wrap things up quick, and that's how I needed to do it. Our final unit that we'll be discussing, it may not be the final one for you, but it will be 4.2, and I'll be discussing projectile motion. Thank you for watching, and that'll be it.